Okay, geometry students, in this video we will be looking at the process of making conjectures, and also we will be looking at some terms in symbolism that are used in geometry. This is a really important lesson. I hope that you'll give me your undivided attention and take some really good notes, and please pay attention. Okay, here we go. Go ahead and get out your things to take notes with. Your first heading today is, and please copy this down, your first heading today is called Finding a Pattern, Lesson 2.1. If you would write that in your notes, please, and also include today's date. Finding a Pattern, Lesson 2.1, and also include today's date, please, if you would. Okay, now, looking for patterns can sometimes help solve a math problem. Let me give you an example that you do not need to write down, but just watch this example, and I think you're going to see how important it is to sometimes look for patterns in a mathematical situation. Watch this carefully. If I asked you to add up all of the integers from 1 to 100 without a calculator, that would take you quite a while. However, if I studied the process of adding these numbers together, I would see that a pattern would help me. Let me show you what I mean real quick. If I have 1 here and the last number is 100, and of course next would be 2, 1 plus 2, and then plus 3. And again, you do not need to take notes on this, just watch please. And then I would have 97 plus 98 plus 99, of course a bunch of numbers in between. Dot, 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 dot. So we start at 1 and we go all the way up to 100. Again, you don't need to take notes on this, just watch. And I realized that if I was going to add up all of the integers from 1 to 100 without a calculator, I could do it actually very quickly. If I take my first number and add it to this number, I get 101. And if I take my second number 2 and add it to 99, I get 101. And if I take my third number 3 and add it to 98, I'll get 101. And if I take 4 and add it to 97, I get 101. And guess what, students? This pattern continues all the way through. So really, all that I have to do is ask myself, how many sets of 2 do I have from 1 to 100? And the answer is 50. So I will have 50 101s throughout this entire pattern. So I really could just take 101 times 50. 0, 5, 0, 5. So there we go. I just added up all of the integers from 1 to 100 without using a calculator, and the answer is 5050 just by looking for a pattern. Now, I went pretty fast through this, and I can definitely explain this better, but I really don't want to, because I'm not trying to teach you right now anything about mathematical sequences or series. I just wanted you to realize that it's real important to look for a pattern. They can really help you with math problems, okay? When finding a pattern, I want you to use these 3 steps, and I would like you to write these 3 steps in your notes if you would, please, okay? We're going to use these 3 steps. Write these down, please. Step number 1, you study the information given. And that's what I did when I had all of my numbers 1 plus 2 plus 3 all the way up to, 97 plus 98 all the way up to 100. I studied my information, okay? And then secondly, I made a conjecture. Now, I know we've not talked about conjecture yet. We're going to talk about that in just a second, but go ahead and write step 2 down. You make a conjecture. And really a conjecture, if you want to make note of this, is like a hypothesis, okay? You're just making an educated guess about the situation that you're dealing with, okay? So, whenever you're looking for a pattern, you first study the information given, then you make a conjecture or a hypothesis, and then lastly, you verify the conjecture. Now back to my example earlier when I had 1 plus 2 plus 3, then over here 98, 99, 100. There was really nothing to prove, because you can see that if 1 plus 100 is 101, and then you go up 1 to 2, but you go down 1 to 99, those two have to equal the same thing, 101. And then if I go up 1 from 2 to 3, but I go down 1 from 99 to 98, it's obvious that 3 plus 98 is going to equal the same thing. So I really did verify the conjecture just pretty much by common sense. So I studied my information, and then I made a conjecture, and then I verified it, okay? And then I was able to find a pattern by using these 3 steps, okay? So I do want you to write down these 3 steps. You need to know those for a test or for a quiz. And by the way, when you use this process, this is called inductive reasoning, and I would also make a note of that in your notes, okay? When you use this process here, you are doing something called inductive reasoning. You're thinking and you're reasoning. Now, I would like you to write this in your notes if you would, please. What is a conjecture? A conjecture is, like I said earlier, an hypothesis, okay? It is making an educated guess based on given information. Making an educated guess based on given information. Please write that down. We're going to look at 2 examples to really help you understand this. Now, listen to me, students. For the first example, I would like you to take no notes at all. Just sit back and listen and watch and just see if you can understand what I'm trying to do. These 2 examples are really tough problems, and probably I would not give you problems like these on a test or a quiz. The main thing I want you to learn to do is to study a situation when you're looking for a pattern, study the information, and then make a conjecture, and then test it and make sure that you're accurate, okay? So let's look at 2 examples that will help you understand making an educated guess based on given information. And again, please don't take notes on this first example. What is the relationship between the maximum number of regions into which a circle can be divided and the line segments used to divide the circle? Let me read that again. What is the relationship between the maximum number of regions into which a circle can be divided and the line segments used to divide the circle? Now again, don't take notes on this, just watch, okay? What I'm going to do is I'm going to try to find that relationship. So here's what I do. I go ahead and draw a circle, all right? And so what I'm going to do is I'm going to draw again, it says what is the relationship between the number of regions in which a circle can be divided and the line segments used to divide the circle. So I'm going to go ahead and put a line segment in here like that, okay? And I just chose that line segment at random, and when I drew that line segment through the circle, I noticed that it divided the circle up into 2 regions, okay? So what that means is this. When I draw one line segment through a circle, it divides it up into 2 regions. Okay, no big deal. I'm going to draw another segment. Watch carefully. And now let's see how many regions I have. 1, 2, 3, 4. So far I can write 2 line segments, 4 regions. Now, if you guys are trying to think ahead and say, Mr. Harrow, I know what you're going to do next, you're going to draw your 3rd line just like this. Well, actually I'm not, and please listen to me carefully, and please watch why. Notice it says, what is the relationship between the maximum number of regions into which a circle can be divided? So if we're dealing with a maximum number of regions, if you think about that for a second, then I really don't want to draw my 3rd line through an intersection point. I want to draw my 3rd line so that it goes through those 2 lines in 2 other places. And by doing that, look what it does. It gives me an extra region right here. Now again, I'm not planning on giving you any problem like this on a test or a quiz. So just relax, listen, and just learn, okay? And don't take notes, just watch this. Unless you want to take notes, you can, but you don't have to, okay? I'm just trying to get you to think here and look for a pattern. So I'm going to draw my 3rd line like this over here. Okay, I wanted this 3rd line to intersect my other 2 lines in 2 different places to give me a maximum number of regions. So now my regions would be, let's count them, 1, 2, 3, 4, 5, 6, 7. All right, so that means when I have 3 line segments, I have 7 regions. Now remember, the next line that I'm going to draw has to intersect all 3 lines, maybe something like this. Okay, something like that. Let's see where I put it. Okay, right there. So I've drawn this 4th line, and notice it intersects one line here, the other line here, and the other line here. So it intersects 3 lines in 3 different places, thus giving me a maximum number of regions. So let's count how many regions I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So when I have 4 line segments, I have 11 regions. Okay, so let's continue on. Now again, if you probably think I'm going to draw my 5th line, I am, but remember, my 5th line has to intersect 4 different lines at 4 different places. So I'm going to go with that line right here, and it intersects the lines here, 1, 2, 3, and 4. Okay, so I've drawn my 5th line, and it intersects all 4 lines in 4 different places. So let's count my regions here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I was just about done counting, but look, there's one right here, it's 15, and there's one little triangle right here, 16, okay? So when I have 5 line segments, I have 16 regions. Now, let me tell you again, students, relax. I'm not going to give you a problem like this. I just want to show you how I looked for a pattern. I noticed when I had 1 line segment, it divided the circle into a maximum of 2 regions. And when I had 2, it was a maximum of 4. 3 line segments was 7. And I kind of see a pattern here. Do you see the pattern? I went from 2 to 4, and then to 7, and then to 11, and then to 16. So I added 2, then I added 3, then I added 4, and then I added 5. So I can make a conjecture here, something like this. As a new line segment was added, the regions increased by the same amount as the last one plus 1 more, or something like that, okay? And so what I'm just trying to show you here is that you can come up with patterns in a situation, and then you don't have to draw 17 line segments to see how many regions it would be. Okay, you could very quickly see that 8 line segments would be what? Well, 6 would be at 6, 22, 7 would be at 7, that's 29, and 8 would be at 8, 37. So there you go. 8 line segments would give you a maximum of 37 regions, unless I made a little mistake right here while I was quickly doing the math, and hopefully I didn't. So hopefully you're seeing what we're trying to do here. Now, let's try another example, and I want you to take notes on this one, okay? So let's take some notes. Here we go. And hopefully you can see the pattern. And by the way, relax. This was an extreme problem. We will not be doing a lot like this, okay? All right. Now, please write this example in your notes. All right. What is the maximum number of regions into which a circle can be divided by connecting n points on a circle? And of course, n points means that I can use as many points as I want to, any given number. Okay, so here's what we're going to do. We're going to look for a pattern and see if we can't figure this out. Okay, so here's my circle, and notice I have 2 points. Here's a point, and here's a point. All right, so when I have 2 points, and there's my line segment, I have 2 regions. All right, so 2 points, 2 regions. Okay, continuing on. Now, I have a point here and a point here. Now, I'm going to put my 3rd point here. So I have a point here and a point here and now a point here. And I could have put that 3rd point wherever I wanted to. I just chose to put it there. And now we're going to connect all these points. So I'm going to take this line. It'll go right here. I'm going to grab this line. It'll go right here. So now I've connected all of my points, and I have how many regions? 1, 2, 3, 4. So when I had 3 points, I had 4 regions. I'm going to pause just for a second in case you guys are getting caught up here, okay? So 3 points, 1, 2, 3, gave me 4 regions. 1, 2, 3, 4. And also, notice it says what is the maximum number of regions. That's why when I put another point up here in a second, I'm going to have to connect all of the points, okay? You connect every single point that's up here, and we'll talk about that in just a second, okay? All right, hopefully you're caught up, and we're going to move on. Now, I chose to put my 4th point right here, so go ahead and do that on your circle. Now, after you put your 4th point in the circle, you then have to connect lines like this. You have to connect this point to that point, and this point to this point, and this point to this point. You want every dot being connected. So this line right here goes right here, and then I'm going to draw this segment here, and then I'm going to draw this one here. And I'm not going to take time and count the regions for you. I'm just going to tell you right now, you'll have 8 regions. If you want to count them, go ahead. 1, 2, 3, 4, 5, 6, 7, 8. But 4 points will give you 8 regions. All right. Now let's go ahead and go with the 5th point. Okay. So hopefully you're staying up with me here. Let's go ahead and put a 5th point on the circle, and we're going to put that up here. Now remember, you must connect all the points. So you're going to draw a line here, and then to that point, and then to that one, and then to that one, okay? So I've got the lines already drawn here, as you can see. So I'm going to draw this segment here, if I can get a hold of it, and maybe I can't. There we go. That segment will go right there, and this segment will go right there, and this segment goes right here. Please copy all this in your notes if you would, please. And that was not what I wanted to do, and that's definitely not what I wanted to do. Let's try this again. And this will go right here. Now, if I count all the regions, I guess I'll do it quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's supposed to be 16, 15, 16. There we go. So when I have 5 points, I have 16 regions, okay? Well, I think we're seeing a little bit of a pattern here. As I increased by 1 point, my regions double. So I guess you could write a conjecture that said every time you add another point onto your circle, the number of regions will double. We went from 2 to 4, so 2 times 2 is 4, times 2 is 8, times 2 is 16. So if I wanted to know how many regions I would have in a circle if I had 8 points, well, that really wouldn't be too hard to do. I mean, 6 points would have 32, you double it. 7 would have 64, you double it. And 8 would have 128, you just double it. And so that's why it's so helpful to look for patterns, to look for patterns in situations like that, and then make a conjecture about the situation, okay? So let's wrap all this up. Through all of this, what am I wanting you to learn? I want you to learn to view a situation, look for a pattern, and then make a conjecture. We will be using this a lot this year when it comes to doing proofs later on this year. Okay? All right, let's continue on. Now, let's move on to our another topic for the day. I told you at the beginning of the class period, we're going to look at 2 different topics, okay? And so go ahead and copy this in your notes if you would, please. Terms and symbolism. Terms and symbolism in geometry, lesson 2.1. Be sure and include today's date if you would, please. Include today's date, terms and symbolism, lesson 2.1, and include today's date. We're going to take a lot of notes, so get ready. Here we go. There are certain terms that are so simple to understand, there is no need to give a formal definition. And let's look at 4 of these quickly. Please write these down, okay? First of all, line. I'm not going to give you a definition for what a line is, but I would like you to draw one in your notes, and I want you to write some things down that you really need to know, okay? First of all, notice a line continues indefinitely in both directions. It's very important that you know that, okay? So I put arrows on both ends. Also, it's very important for you to know that a line is named by 2 points. So we could call this line AB, or we could call this line line AC, or we could call this line BC. Any of those would be acceptable. So I would definitely write all this down and take notes on this, okay? Also, sometimes a line will be denoted by a small cursive letter, like maybe a little L off to the side. So we would call that line L. Or it might have a little cursive A, line A, or a cursive M. We would call that line M. So either one of those two ways are a normal way to name a line. Okay? Go ahead and write this next one down if you would, please. A segment. Now, I'm not going to give you a formal definition as to what a segment is, but please take some really good notes on this. A segment does not continue indefinitely in both directions. A segment has two endpoints, okay? And a segment is usually named by its endpoints. If I have an E here, please take some really good notes on this, and an F here, I could call this segment EF, and you just put a little line like that. You don't put arrows on the end, and you don't put points on the end either like that. You just simply put a slash, and you say segment EF. Now, unlike a line, remember the last line we had A, B, and C, and we could call it line AB or AC or BC. Not so with a segment. If I had a G right here, and I put down segment EG, that's fine, but segment EG would mean only from here to here where G ends. Okay, so be really careful as you name your segments, okay? And this is how we're normally going to name segments, with two letters, the endpoints. Okay, so a line continues indefinitely in both directions, and a segment has endpoints on both ends. All right, go ahead and write down ray, the word ray. Now, a ray will look like this. It'll have an endpoint on one end, and it will have an arrow on the other end, like this. And this is what a ray looks like. So one end of a ray continues indefinitely, and the other end of the ray has an endpoint. Okay? Now, we name a ray like this. Please take some really good notes on this, please. We're going to put an X here and a Y here. Now, we call this ray XY, and look at the symbolism or the denotation here is like this. Now listen to me, students. It would be incorrect to write this ray YX. That would be incorrect. Ray YX would look like this. The Y would be here, and the X would be here. Do you see what I'm saying? In other words, when you name a ray, whatever the endpoint is, that's what you have to start with first. So the endpoint of the ray was X, so I called the ray XY. If the Y had been here and the X had been over here, then I would call this ray Y. I'm not sure why I put a Z there. Ray YX. Okay, so understand what a ray is and understand how to name this. I'm going to pause just for a second in case some of you need to get caught up on your notes. Okay, continuing on, let's take a look at one more word. Opposite rays. Should be an S there. Opposite rays. Okay, now opposite rays are just simply two rays going in complete opposite directions, and they share a common endpoint. Okay, and they're always going to equal, by the way, 180 degrees. Always. Okay, because it's a straight line. All right, this would not be opposite rays. Something like this. Okay, they're almost going complete opposite directions, but they're not. Opposite rays are two rays that are going completely opposite directions with a common endpoint. You could have a ray going up like this, and then a ray going like this, and those two rays are opposite rays. They have a common endpoint, and they're going in complete opposite directions. Okay, so you need to know what opposite rays are. Okay, let's continue on. Now let's look at some terms in which I do want you to know the formal definition. So you do need to know these. Take really good notes on these, and you will be responsible for these on tests and quizzes, okay? Definition of an angle. An angle is two different rays that have the same endpoint. Let me say that again. Two different rays that have the same endpoint. So in other words, we have a ray going this direction and a ray going this direction. Go ahead and write this in your notes if you would, please. And this is called an angle, okay? Now, I really want to give you a bunch of notes on this, so please write this down. This is very important you see everything I'm going to tell you right now, okay? Okay, now let's first of all talk about naming this angle, okay? We call this angle A, B, C. Or we also can call it angle CBA, okay? But you cannot call this angle BAC or BCA. Whatever the vertex of the angle is, and that's where the two endpoints meet at an angle right here, that letter is the one that has to go in the middle. So we can call this angle ABC, or we can call this angle CBA. Now, also in this situation here, and please take some really good notes and pay attention, we can also call this angle simply angle B. You're allowed to do that as long as there's no confusion as to what angle you're referring to. And obviously, if I say angle B, it means this angle right here. However, let me show you something. If I were to throw another ray in here like this, now you could no longer use the phrase angle B. Do you see why? If you said to me, Mr. Earhart, look at angle B, I would not know if you're referring to this angle here or if you're referring to this angle here. Okay, and so because of that, you're welcome to use the single letter names for angles as long as there's no confusion and it looks something like this. Okay, but as soon as you throw another ray in like this, then we're going to have problems. And by the way, let's put a point right here and call this D. So this top angle right here with one dot, we would call that angle ABD or angle DBA. And this angle down here with two dots, we would call this angle DBC or CBD. And of course, the entire big angle right here, we would call that angle ABC. All right? Now, students, there's a couple more things I want to show you, and then we'll be done with talking about angles, and the material will move a lot faster, okay? Let me show you one more thing, and you can take notes however you want to. There's three parts to an angle that you need to be familiar with. I'm going to sketch a real quick angle up here, okay? And you need to be familiar with these three parts. Well, first of all, this is not one of the parts of an angle, but do know that when I say, you might want to make note of this, when I say the vertex of an angle, I am referring to this point right here, okay, where the two rays intersect. Having said that, an angle is known to have three parts to it. It's very important you know these words because we're going to use them a lot in geometry this year, okay? This is called the interior of the angle. Okay? Please write that down. And this is called the exterior. I'm just going to put EXT for right now to save time. Exterior. And so all of this space here, students, between the two rays, and if the rays were to continue on, this space would also continue on. All of that space there is called the interior of the angle. Now the exterior part of the angle is all of the space that's on the outside of the angle. Okay, so there's two parts to the angle. And then the third part to an angle is just the actual angle itself. So we refer to this as the angle. Okay, so there are three parts to an angle. I guess we could say the rays if you wanted to. So there's three parts to an angle: the interior, the exterior, and the actual angle itself, or the actual rays itself. And you do need to know that. Okay, all right, moving on. I'm going to go really fast through this information because this is old math that you should know from years ago. So here we go. Let's look at four types of angles. Here we go. First of all, write this down. You need to know what an acute angle is. It is an angle that is less than 90 degrees. An angle that measures less than 90 degrees. A right angle. It's an angle that measures exactly 90 degrees. You should know that, and we call that a right angle. Okay. Third type of angle, and I know I'm going fast here. At the end, I'll pause and let you get caught up. Okay. Number three, obtuse angle. That's an angle that's greater than 90. Let me pause now and tell you, when you get into trigonometry, we're going to deal with angles that are bigger than 180. We're going to deal with angles that are bigger than 360. They go like this. And that would be 720 plus, that'd be a 765 degree angle. I believe I did it quickly in my head, okay? But in geometry, in standard geometry, like we're doing, angles are understood to be no greater than 80, okay? So an obtuse angle is an angle that's greater than 90, and usually we say it's also less than 180, but we don't need to include that in our definition because in geometry the angles are never going to be greater than 180 degrees. So we're just going to say for an obtuse angle, it is an angle that is greater than 90 degrees. And then the fourth type would be a straight angle, and that's an angle made up of made up of two opposite rays, and they measure 180 degrees. And we've talked about that already up here, okay? And we call that a straight angle, okay? It's an angle made up of two opposite rays, and this measurement will be 180 degrees, okay? So that's pretty much standard. You probably learned this in elementary or middle school, but just a quick review, okay? And then lastly, one other thing, you need to understand what adjacent angles are, and then we're finally done. But it's very important that you know what adjacent angles are. The reason for that is we're going to have postulates and corollaries and theorems that refer to adjacent angles, and you have to know what they are, or the theorem's not going to make any sense. So adjacent angles are, please copy this in your notes, two angles that share a common vertex, and they also share a common side, but they have no common interior points, okay? So two angles that share a common vertex and a common side, but they have no common interior points. And let me give you a picture of this so you can see what I'm talking about. I'm going to call this angle 1 and this angle 2. Angles 1 and 2 are adjacent angles. And do you see why? Here's angle 1. And notice angle 1 has a ray right here. Now here's angle 2 right here. And notice how angle 1 and angle 2 share a common side. And notice also angle 1 and angle 2 share a common vertex right here. So we have two angles that share a common vertex and a side, but have no common interior points. Here's the interior of angle 1 up here. Here's the interior of angle 2 down here. They do not share any common interior points. You could actually have adjacent angles like this. You could have a straight line and then a line coming off of it like this. And those two angles would be adjacent. We'll call this angles 3 and 4. because here's angle 3 right here, here's angle 4 right here, and they share the common side and they share a common vertex. So understand what adjacent angles are. Two angles that share a common vertex and a side but have no common interior points. Okay, I've given you a ton of notes today. I hope you guys have listened well and taken really good notes on this. If you have any questions, don't hesitate to call or email.